Physics of light. So what is light exactly? Is light particles? Waves? What's the difference? Maxwell suggested light was waves, having wavelength affecting color and amplitude affecting brightness. This theory held sway in Maxwell's equations until Planck and Einstein came around. They suggested light consisted of particles, known as photons, little packets of energy moving extremely fast. Its brightness dependent on the amount of particles, and its color dependent on how much energy the particles have. The speed of light is 3.0 times 10 to the 8th meters per second, or 300 million meters per second, aka 1,080,000,000 kilometers per hour. So, who's right? Well, light has dual nature, acting both as waves and particles. Light is a form of electromagnetic radiation. Other forms include radio waves, microwaves, infrared, visible light, which include the colors we see, ultraviolet, X-rays, and gamma rays. Radio waves transmit the latest hits and news across great areas. Microwaves are used in kitchen appliances known as, you guessed it, the microwave, to heat up our food by vibrating the water molecules inside. Infrared waves or infrared light are used to detect heat signatures in darkness, through water, or even through solid objects. Visible light includes the light we can see and the colors that we can see, including red, orange, yellow, green, blue, and violet. Ultraviolet waves are the harmful portion of the sun's rays and are a major concern when tanning. These waves can alter the DNA within your skin cells, causing cancer and other abnormalities. X-rays are used in modern medicine by doctors to help them observe our bones without cutting us open. This also helps them find full breaks and even fractures. Gamma rays are short, high-frequency waves and are extremely harmful. For this video, we'll focus on a sub-portion of the electromagnetic spectrum, the visible spectrum. The sun emits, among other forms of radiation and other things, white light. White objects reflect all light waves. Black absorb all the light waves. And colored objects absorb all the light waves except for that one color. This is due to the object's molecular buildup. Electrons absorb some of the energy from the electromagnetic radiation and jump to a higher energy shell within the atom. When they fall back to a lower energy shell, the energy is expelled as a photon. This photon will have the exact energy the electron gave up. This photon, in turn, will travel in an electromagnetic wave and can be interpreted by our brain as visible light or by our bodies by higher forms of radiation, such as gamma rays, which are, like stated before, quite harmful. Ever wonder what would happen if we lost all rulers? How would we know how long a meter is, or how long an inch is? I mean, we'd have no reference point, right? Not exactly. If we know that light moves 300 million meters per second, then in 1/300 millionth of a second, then it moves 1 meter. So if we can measure that distance with that time, then we would never need a ruler again.